there is a widespread misconception that cesium chloride structure is body centered cubic. So, I want to clarify that. I have already mentioned this in the previous video, but I want to use this video to further clarify that confusion. So, monatomic BCC crystal means a body centered cubic lattice with one atom motif at each lattice point, that is the monatomic BCC crystal. So, this is what should, if we say BCC and mean crystal, we are actually meaning body centered cubic crystal. Otherwise, BCC should actually stand for BCC lattice, which does not have any atom anyway. It has lattice points at the corner and a lattice point at the center of the cube. But if we are saying BCC crystal, or we are implying crystal by saying BCC, it should be actually a monatomic BCC crystal with one atom sitting at each lattice point. This is our BCC. But cesium chloride we have seen that has chloride ions sitting at the corners, but cesium ion sitting at the body center. So, the corner ion and the body center ion are not equivalent. The corner point and the body center point are not equivalent lattice points. So, the equivalent lattice points are only at the corners. This is because of the occupancy of corner and body center by different ions. So, this is no more a lattice translation vector. This is not a translational symmetry. So, this was a translational symmetry or a lattice translation of monatomic BCC, but this is not a lattice translation in cesium chloride. So, the structure changes, the lattice changes. Instead of BCC lattice, we have a simple cubic lattice, and we will have to select two atoms as motif, a chloride ion sitting at the lattice point with a cesium ion shifted by half as we have seen. But in many textbooks and on web, there is a widespread misconception where cesium chloride crystal is sometimes called BCC, because there is an atom in the body center, but they all, or ion in the body center, but since that ion is not the same as the corner ion, it is not body centered cubic. Even Feynman in his famous lectures in physics has made this mistake.